Hi, I'm Alex,
I'm Adam.
I'm Jonathan.
and for this hackathon, we built our project called ProPay. So ProPay is a real-time credit card processing solution with intelligent fraud detections. As depicted by this diagram here, it will just take in input transactions, do processing and detect fraud, and the results can be either stored for data for analysis, as well as they could also potentially be sent back to the user's email or phone to alert them whether their transaction was successful or not. So as a high-level over architecture, this is basically how our stuff worked. End users are able to submit their credit card info, essentially their transaction, over our web app, and this data will be forwarded to our backend API, which acts like a proxy in that the sense that it just basically forwards all the data to the real-time data streaming called Apache Kafka, which streams data in and out directly to our Apache Spark application. This is where it performs the data processing, and our algorithm is implemented here where it detects fraud, and all the results are then appended and loaded into an Excel CSV file, which basically indicates whether or not the stuff is fraudulent or not. So in regards to the web app and API, we just use a simple React app for the web app and a Node.js Express backend for the API, which would then write the results out to Apache Kafka. So now, in regards to the data streaming with Apache Kafka, just to give you all an overview of what it does, it basically maps multiple inputs out to multiple outputs. It takes care of the complexity of data streaming for us. And the inputs are coined as producers, and the outputs are called consumers. The producers send the messages to what are known as topics, which are then subdivided into partitions. So now into the meat of our application is where we worked on Apache Spark. And essentially what it does is what is known as extract, transform, and load, or shorthand for ETL, where it extracts the information from the Kafka streams, does its transformation on the data by cleansing it. So let's say there's missing data, and as well as reformatting malformed data. Then it runs through our algorithm to detect fraud, giving each thing a score and a true or false Boolean to indicate whether it's fraudulent or not. And then it would load the results into the Excel CSV file. Now, this is where the real power of Apache Spark comes in. It has this clustering capability where it performs what is known as elastic MapReduce, or EMR for short, where it maps all the input data out to multiple servers in parallel, where it does its processing and shuffling and then our algorithm on it. And then it reduces the results back into one output where we can save it. And now Adam will go over how the fraud detection algorithm works.
The algorithm is used to check if a transaction is fraudulent or not. Initially, I created the algorithm using Google Sheets so I could determine exactly how I wanted the algorithm to work before ultimately writing it in Scala. The algorithm works in two stages. First data is fed into the algorithm for a given transaction. This data includes the card number, expiration date, billing and shipping address, as well as other relevant fields. This transaction data is then fed into the first stage of the algorithm, where it verifies that the transaction is valid. To do this, it does a handful of basic checks, including running the card number through the Loon checksum algorithm, verifying that the card is not expired, and checking that the billing address is valid. If the data passes the first check, then the second stage of the algorithm begins, where the algorithm looks at other features of the transaction, such as validating the other transaction details, comparing the shipping and billing addresses, and checking if there's a history of chargeback, fraud, or criminal activity. Through this, it assigns the transaction a score from 0 to 100. If the score is above 80, then it is classified as a valid transaction. Otherwise, it is classified as fraud. The score and a Boolean value indicating if it is fraudulent or not is returned by the algorithm. Now I will briefly show my Google Sheet that I use to make it. So I have a sample row as well as the basic or first stage of the algorithm. It is kind of an outline of what I wanted it to do, as well as the advanced test or second stage and another outline. And here's the Scala code with the basic test or first stage again, and the advanced test or second stage. I also have the Loon checksum algorithm and valid address helper functions. And I also wrote a handful of basic unit tests to just verify that the algorithm was working as intended. And now Jonathan will give a demo of our project.
All right, so I'm gonna go ahead and make sure, can you see my screen? I think I
Yes.
shared the right one. Okay, so this is a quick run through of how it works. So I'm gonna go ahead and put some sample information. Also ignore the promo code stuff. We were using a template and we didn't, due to some negligence, we were kind of fast with that. And okay, so I'm gonna make sure that I have the phone number in the correct format that it needs to be in. This could be my email, and then I'm gonna say that my shipping address is the same as for this case. Just go ahead and put any name. And then for the credit card, I'm gonna copy and paste a credit card number that actually passes the checksum uh, algorithm, just to make sure that it's valid, and then have a sample CVV. And then I'm gonna unmaximize out of this. And then this looks a little complicated, so I'm just gonna talk about this. So the top left is the API, and it's sort of gonna indicate that the data was passed through. And then the bottom left is the Kafka streaming service. This is the consumer side. So that means that this is the part that sort of makes it to the other side and then does the allocation, the cleaning of the data. And then this is the CSV file where the score is going to be outputted as long as, or as well as any more additional information. So I'm going to go ahead and submit this, and then it passed through here. And then we can see now it just passed through this row. Uh, and then if I leave this data CSV file and then return, you see the indication that it passed the test. So this is all the way in the end. It's valid. It has a valid score. And then just to show, I'm going to change the credit card number so that it won't pass the checksum. So I'm going to pass this through. It went through here, and then we just see it load in as well. And we just scroll it down. Yeah. So there's the next iteration. I go back in here and it does not pass. And then we can see if I just submit a bunch of times, they're all passing through. Um, And let's see, let's say there's a case where uh, this is the shipping address is different from the mailing address. And let's say the country was a different country. Um, let's say this was, I don't know, NW. Uh, and yeah, set this back to normal so that it would at least pass the checksum. And then something that doesn't look very valid as a name, I guess null. And we can go ahead and change the email, something called null as well, just to uh, it's just to make sure that it's working as intended. So I'm going to submit that. There's another entry here. And then if I leave this file and then enter back again, so it did not pass again, even though it has a score of 70. So the way we have it at the moment, if it has a score less than 80, then it would not pass, and this Boolean would be set to false. And let's see, that's pretty much it in terms of how the workflow is. It just goes from uh, this cool looking website. It goes to the API at the top left, then it goes through the stream and then gets appended into this file. So that's it in as far as the demo. So we can continue on with the slides.
All right. So one more thing we did, as you may have saw earlier, we did some unit and integration testing on our Apache Spark application. We also did some manual GUI testing on the web app. And one more cool thing we did was we did a load test on our API to see how much, to simulate how many users are coming into our website and then processing transactions if we could handle the load. So we used Apache JMeter for that. And I'll just give you a little demo of how it ran. Basically, I configured 200 users to run at a time, and it would read off of the simulated data that I generated with a Node.js script. And this is kind of the data it would be passing through. It's all the same stuff from a website. So let me just click run and show you what it does. So as you can see, it's running all 200 users simultaneously, and all the data is being passed through. As you can see, each one's different. And as you can see, all the responses are successful. And here's a summary report of 0%. And as you may have noticed, let me just run it again in case you missed it. All the data
You're
gets
sharing your slides instead of the test.
Oh, really?
You're sharing the, yeah.
Oh, my bad.
All right.
Okay. Can you guys see everything now?
Mm-hmm.
Okay. My bad. Yeah, so here it is. I'll just sort of go over it again. It ran 200 users simultaneously in my JMeter script. And this is kind of the data that it's passing through, reading off of a CSV file, which is generated from a Node.js script. And so I'll just run it again. And it runs all 200 users. As you can see, the responses are being captured by the Kafka consumer stream here. And the response data is here. And the requests, as you can see, are all different with different users. And as a summary report, we got 0% error. So we know our web application is pretty good at handling a large amount of load. So continuing with the slides, Adam will now go on to talk about our experience with the project.
The biggest challenge we ran into was communication, because multiple times during the project, there was confusion between team members about the requirements for different parts. In addition, connecting our different parts also presented a challenge due to questions about input and output class data types, as well as difficulties merging our projects with GitHub. Despite our challenges, we were able to develop a fully functioning application, including the front-end website, streaming of the data with Kafka, and the back-end analysis of the data with the algorithm.
If you go to the next slide. Thanks.
And onto what we learned. We learned a lot about big data technologies, including the programming language Scala and the tools Kafka and Spark. In addition, we also learned about fraud as it relates to finance and detecting it. And finally, the next step for ProPay is implementing a machine learning algorithm for the second stage of the algorithm that would learn to detect fraud based on historical data, relationships between the billing and shipping addresses, such as someone's working office in their home, and to parse the details of the person's chargeback, fraud, and criminal history. In addition, we could utilize geographic information system approaches to improve upon both parts of the algorithm. In the first part, we could use a reference database to verify that the billing address actually exists, rather than just following the correct format. And in the second part, we could calculate the distance between the shipping and billing addresses to use when calculating the score for that transaction. With that, thank you for listening to our presentation. And are there any questions?
Good job, guys. I guess, how did you guys decide to use like the tech stack that you did?
Basically, we took experience by looking at different software solutions. AWS, which is Amazon's web service, they have a list of various architectures for doing big data processing. One being like processing of transactions. So I kind of learned from how taking existing examples of how companies would do it, as well as doing research online and watching plenty of YouTube tutorials, as well as like Udacity tutorials, free courses. And that's how we kind of learned how to develop this solution and all these technologies.
Were any of these like technologies new for any of you, or were you all well versed in it?
Just for me and Adam, I think it was our first time ever working with Scala and Kafka and Apache Spark. So
Yeah,
yeah,
same for me too.
yeah, pretty much almost all of it. But
Yeah, we've worked with big data technologies before, but using a simpler version. We didn't use any of these kind of hardcore technologies. We used like simpler, basic ones, which abstracted a lot of the complexity from us. These ones are more involved and provide a lot more configuration ability.
It didn't seem like you were new to it at all. Your app looks great, and you put a lot of thought into your presentation as well.
Yeah, thank you. Yeah, it was a lot of fun.
Yeah. Would you use the same tech stack again next time, or?
Yeah, we're actually going to continue this project on as part of one of their clubs that we're participating in, known as the App Development Club at OSU.
Cool. Well, I hope to see more updates in the future. It looks great.
Yep, thanks.
thank you.
Thank you.